right? Soil has to be fertile. That means soil has to contain the necessary nutrients that will support plant growth. So soil conservation can be done by maintaining soil fertility, by reducing or eliminating soil pollution. Soil pollution, that is introduction of harmful products, substances to the soil, and also preventing soil erosion. Preventing soil erosion. So learners, soil conservation, I'm repeating, can be done through maintaining soil fertility, soil conservation, can be done by maintaining soil fertility. Learners, I hope as I'm writing, you also make sure you write. Okay? Then reducing, we're saying here, soil conservation can be done by 1, maintaining soil fertility, reducing or eliminating soil pollution, reducing or eliminating soil pollution, or avoiding or preventing soil erosion, and preventing soil erosion. Preventing soil erosion, because soil erosion causes the soil to lose its fertility. So soil conservation can be done by maintaining soil fertility, reducing or eliminating soil pollution, or preventing soil erosion. In standard 7 again, we learned ways in which soil can be polluted. We learned ways in which soil can be polluted. So now, what methods can we use in order to conserve soil? Soil conservation methods. Soil conservation methods. Let's discuss soil conservation methods. Soil conservation methods. What are these methods that we can use in order to conserve the soil? Now, learners, there are different methods which can be used to conserve soil. There are different methods that can be used to conserve soil. There are different methods that can be used to conserve soil. So learners, I'm going to list these methods down. I'm going to list them down first, then we'll discuss the methods one by one. Number 1 is avoiding excessive use of fertilizers. Avoiding excessive use of fertilizers, insecticides, pesticides, and so on. Avoid excessive use of fertilizers, insecticides, pesticides, herbicides, can add herbicides, etc. Avoid excessive use of fertilizers, insecticides, pesticides, herbicides, and so on. Number 2, or B, avoid dumping of waste on soil. Avoid dumping of waste on soil. That is the second method. Number 3, avoid burning. Avoid burning vegetation cover. Avoid burning vegetation cover. D, mulching. E, planting cover crops. Planting cover crops. F, making terraces. F, G, contour farming. H, planting trees. Planting trees. Then we have HI, learners. We've said we are listing soil conservation methods. First one is avoid excessive use of fertilizers, insecticides, pesticides, herbicides, etc. B, we've said avoid dumping of waste on soil. C, avoid burning vegetable cover. D, mulching. E, planting cover crops. F, making terraces. Okay. G, contour farming. H, planting trees. I, constructing gabions. Construction of gabions. Then we have controlled grazing. Controlled grazing. So this is controlled grazing. So these are some of the methods that we can use to conserve the soil. So how many methods are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Controlled grazing learners can also be known as proper stocking. Let's write or proper stocking. Goes hand in hand with proper stocking. So learners, we are going to discuss each and every method one by one. In this lesson, we will learn about avoiding excessive use of fertilizers, insecticides, pesticides, herbicides, and so on. So let's explain. I'm going to explain the first method, which is avoiding excessive use of fertilizers, insecticides, pesticides. We also have herbicides, etc. Now, learners, fertilizers, pesticides, and herbicides contain chemicals which cause soil pollution when the substances are applied in excess. We are talking of excessive. When insecticides, when herbicides, when fertilizers are applied in excess, that can cause soil pollution. Why? Because these fertilizers, pesticides, and herbicides contain chemicals which can cause soil pollution, and that happens when they are used in excess. So learners, we should therefore avoid excessive use of these chemicals, and we should strictly follow instructions when using them, because instructions are always given by manufacturers on how to use these chemicals. Another way to avoid excessive use of these chemicals is to use manure instead of chemical fertilizers in order to improve soil fertility. So where possible, learners, farmers should also use biological methods of pest control and insect control, instead of using pesticides, instead of using herbicides and other chemicals that contain poison that may pollute the soil. Is that clear, learners? That is the first method, avoiding excessive use of fertilizers, insecticides, pesticides, herbicides, and so on. Because you have said these fertilizers and chemicals and pesticides, they contain chemicals which cause soil pollution. And that happens when these chemicals are applied in excess. So instructions should be followed on how these chemicals are applied on the soil. And we've said that farmers should instead use manure, and where possible they should use biological methods in controlling pests, controlling insects. So learners, that will mark the end of our today's lesson. In our subsequent lessons, we are going to discuss in detail the other methods of conserving the soil, that is avoiding dumping of waste on soil, because this dumping of waste on soil can be done by industries and factories. They can also be done by people, okay, domestically. So we will be discussing all these other methods in our following lessons. Today we will stop at that, but just to recap what we've done in our today's lesson, learners, we introduced soil conservation, whereby we also defined soil conservation as the act of protecting the soil from pollution or or destruction by natural or human activities. We've said that soil conservation involves proper use, care, and protection of soil. And soil pollution, we said, also can be done by maintaining soil fertility, reducing or eliminating soil pollution, or preventing soil erosion. Then we have listed the various methods or different methods that can be used to conserve soil. One is avoiding excessive use of fertilizers, insecticides, pesticides, herbicides, and so on. B, avoid dumping of waste on soil. C, avoid burning vegetation cover. D, mulching. E, planting cover crops. F, making terraces. G, control farming. H, planting trees. I, construction of gabions. Then lastly, controlled grazing or proper stocking. So learners, before we stop the lesson, I'm going to give you assignment. This is your assignment. Question 1, what is soil conservation? Question 2, list 5 methods that can be used to conserve soil erosion. Go through the video once more, then close your exercise books and then do the assignment. Thank you for your attention and God bless you.
Enroll your child with the manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a course-friendly format.
Welcome to our physics lesson today. My name is Purity Anzelimo, your teacher of physics. In our lesson today, we continue with the cathode rays and the cathode ray tube. That's our topic. Cathode rays and the cathode ray tube. During our previous lesson, we have been looking at the parts of a cathode ray oscilloscope, and we were able to know that a cathode ray oscilloscope is used in the production of cathode rays, and we were able to see the 3 major parts of a cathode ray oscilloscope, namely the electron gun. We also have the deflecting system and also the screen or the display system. So those were the major parts, or those are the major parts of a CRO. In the electron gun, we have the cathode, that is the heated cathode, the ground, and the anodes. In the deflecting system, we have the X plates and the Y plates. And in the display system, we have the screen. So during our lesson today, we continue with the cathode ray oscilloscope, but now we want to look at the uses of a CRO. So uses of a CRO, uses of a cathode ray oscilloscope. And we are going to look at 2 major uses of a cathode ray oscilloscope. We are going to explain each one of them. So one of the uses of a cathode ray oscilloscope is used as a voltmeter. So number 1, used as a voltmeter. A cathode ray oscilloscope is used as a voltmeter. We know from the topic current electricity, we know that a voltmeter is a device that is used to measure voltage. So we have the CRO being used to measure voltage. So we are going to explain how. Then again, we can use a CRO to determine the frequency of an alternating current signal, used in determining the frequency of an alternating current signal. So we will also explain how a CRO can be used to determine the frequency. Remember, we know what frequency means. When we talk of frequency, simply refers to the number of complete oscillations in 1 second. So it can also be used in determining the frequency of an alternating current signal. So I want us to start with the first one. We have seen that a cathode ray oscilloscope can be used as a voltmeter. So CRO is a voltmeter. Our CRO as a voltmeter. And we are going to see that the cathode ray oscilloscope will have many advantages over the voltmeters that we use, the ordinary voltmeters that we have. So when we are using the cathode ray oscilloscope as a voltmeter, when the time base is switched off, with the time base switched off, when we have our time base switched off, then we also have the X plates being earthed, X plates earthed, and then we have the voltage to be measured, connected, and voltage to be measured, connected to the Y plates. So this is what we are going to have. So when we have the time base switched off, remember we said that the time base is connected to the X plates, and now we want to, and the X plates are earthed, and then we have the voltage to be measured, connected to the Y plates. Then we are going to have that the voltage, these are the Y plates. Remember we said there are two. So the voltage will be given by the displacement multiplied by the sensitivity. And in the sensitivity, that is simply the volts per division. Sensitivity is simply the volts per division. So when we have the time base switched off, the X plates earthed, and the voltage to be measured connected to the Y plates, then we can calculate the voltage as displacement. Remember, we said that in the deflecting system, we have these Y plates which are responsible for the vertical deflection. And that's why we are talking of the displacement. We are going to apply this in our numerical calculations. So voltage will be given by the displacement multiplied by the volts per division. And in this volts per division is also referred to as the sensitivity. So that's how we can use a CRO to calculate the voltage. Or that's how a CRO can be used as a voltmeter, and we are going to employ this in our calculations. So note, voltage is equal to displacement multiplied by the volts per division. And as I've said, a voltmeter is a device that is used to measure voltage. And therefore we have our other voltmeters, the ordinary voltmeters. But now we are saying that the CRO is advantageous or has more advantages over the ordinary voltmeter, and we look at those advantages. So we look at advantages of the CRO over the voltmeter. Advantages of the CRO over the ordinary voltmeter. Now, a CRO as a voltmeter, we have seen that can be used as a voltmeter. What are the advantages of the CRO when used as a voltmeter over the ordinary meters? So one of the advantages is that it can be used to measure both direct current and alternating current voltages. That's number one. Remember, for the voltmeters that we have or that we use in the lab mostly, they are only used to measure direct current voltages. So, but for the CRO, can be used or can measure both the direct current and the alternating current voltages. So that's one of the advantages of a CRO over the voltmeter. Then we can also say that it can also be used to measure large currents. It can be used to measure large, not currents, but voltages, because it's used as a voltmeter. It can be used to measure large voltages without being destroyed. We know in the voltmeters that we use in the laboratory, most of them ranges from 0 to 5 volts, others from 0 to 3 volts. But now for the CRO, it can be used to measure larger voltages. So can measure larger voltages compared to the ordinary voltmeters. So it can be used to measure larger voltages compared to the ordinary meters, and it cannot be destroyed. So without being destroyed. That is another advantage of a CRO over the ordinary voltmeters. Then we know very well when we are using the voltmeters, that is in electricity, when we use the voltmeter, when you want to read the screen or the reading, we usually check where the pointer, how the pointer moves. If, for example, this is my pointer, these are the readings here on the voltmeter. We know very well that this pointer, when you want to get the reading, it swings fast. It swings around the reading. It swings and then it points where the reading is to be. And the reason as to why it swings before getting to the point where the reading is due to inertia. Which we discussed also in the Newton's laws of motion. So as a result of inertia, then this pointer will swing momentarily about the point or the actual reading. But for a CRO, it's not affected by inertia. And therefore the reading will just be read directly instead of the pointer having to swing about the point where the reading is to be taken. So that is another advantage of a CRO. So we can say that it responds at an instant or instantaneously responds instantaneously, unlike the ordinary meters which swing, or which, unlike the ordinary meters, we can talk of whose pointers are affected by inertia. So they will sing about the point and before they show the actual reading. But now for a CRO, it will respond instantaneously, unlike the ordinary meters, which we are saying the pointers are affected by inertia. Then we can also say that with the CRO, another advantage over the ordinary meters, another advantage, number 4, we can say that the CRO has a very high resistance. It has an infinite resistance, and therefore it does not take any current. It has very high resistance, any current. It has a high resistance hence does not take any current. From current electricity, that is on Ohm's law, we know very well that Ohm's law relates voltage to resistance, that is V is equals to IR, and we are saying that a CRO has a very high resistance. This is very high for a CRO, and that means when it is high, it is not going to take any current or even any voltage. The voltage and the current are not going to be affected when the value of the resistance is high, because from this we know that the current will be equal to V all over R, and we are saying that when this is very high, then it's not going to affect this current. It's not going to take any current, because if it were low, it means that then this will be affected. The current will be affected for us to get the voltage, because it's being used to measure the voltage. So it has a high resistance, or what we are calling infinite resistance, and therefore it does not take away any current. So those are the uses of a CRO. That the first use, which we have just discussed, that it is used as a voltmeter, and we are saying that when the time base is switched off and the X plates are at, the voltage can therefore be measured, or can be measured while connected to the Y plate. And voltage, we have seen, will be given by the displacement multiplied by the volts per division. And then we have also explained why the CRO is preferred to the ordinary voltmeters. It has the following advantages. We have mentioned 4 of them. It can measure both direct current and alternating current voltages, unlike the voltmeter, which only measures the direct current voltage. Then it can measure larger voltages compared to the ordinary voltmeters without being destroyed. We have also seen that it is not affected by inertia, so it can respond instantaneously, unlike the other meters. Then we've also seen that it has infinite resistance, and hence it does not take any current away. So we want to look at the other use of a CRO, use number 2, where we have seen that it is used in determining the frequency of an alternating current signal. So used to determine the frequency, CRO to determine the frequency, used in determining frequency that is of an alternating current signal. And in this one, the signal is fed into the Y plates. The signal is fed into the Y plates. The signal is fed into the Y plates with the time base on. The time base is on, with the time base on, and we are saying that the time base control is then adjusted. The time base is controlled. The time base can be controlled. The time base control, is adjusted to give one. It is adjusted. The time base control is adjusted. So this time base, remember, it is on the X plate, is adjusted to give many cycles as possible. It is adjusted to give more cycles, So remember, in this, we are going to have the formation of the cycles. We can have it here. So there will be formation of the cycles. we can have this. That's what we are going to have. So we are saying that when the time base is on, and this time-based control is adjusted to give more cycles. And therefore from this, then we can say that when we want to calculate the frequency, the periodic time is recorded, the time, or what we call the periodic time is the time taken to complete one cycle. This time which is taken to complete this cycle, the time which is there is what we are calling now periodic time, represented using a capital letter T. And we can say that the periodic time is determined. It is determined by relating the trace of the signal by relating the trace of the signal on the screen with the time-based setting. So the periodic time is now being determined by relating the trace of the signal, which we have seen, the trace of the signal on the screen with the time-based setting. So we can be able now to get the periodic time because we are saying that the time base is on. So when we get the periodic time, then we can now be able to calculate the frequency F. By the formula, frequency is simply the reciprocal of the periodic time, T. And therefore, we can be able to calculate frequency by getting the reciprocal of the periodic time. So that's how we can use a CRO to determine the frequency of an alternating current signal. Because when we get the periodic time from the connections whereby we are seeing the signal is fed into the Y plates, then the time base is on, the time base control is adjusted to give cycles many as possible, and therefore the periodic time is determined by relating the trace of the signal, this is the signal on the screen, with the time base setting. So with this we can be able to get the periodic time and hence able to calculate the frequency. So the frequency will be the reciprocal of the periodic time. So those are the two uses of a CRO. One used as a voltmeter, and we have seen that the voltage here will be given by the displacement multiplied by the divisions, that is the sensitivity. And then we have also seen that it is used in determining the frequency of an alternating current signal. So those are the two uses, and you should be able to explain how it is used. In this, we are going to do more calculations. We'll apply this formula in our calculations. We'll also apply the formula on calculation of voltage, which we have seen being given by displacement multiplied by the sensitivity. So we want now to compare a cathode ray oscilloscope to a TV tube. We want to look at the differences that are there between a cathode ray oscilloscope and the TV tube. So we look at those differences. So differences between a CRO and a television tube. So what are the differences between the two? Differences between a cathode ray oscilloscope and a TV tube. So we can just have a table. On one side we can have the TV tube, and on the other side we have the CRO. So this is our TV tube, Then on the other side, we have the CRO. So we want to see what are the differences between a cathode ray oscilloscope and a television tube. So one of the differences for a television tube, the deflection here, the deflection is by magnetic field. Whereas in a CRO, the deflection is by electric field. So you need to know that in a TV tube, the deflection is by the magnetic field, whereas in a CRO, it's by the electric field. Then a TV tube has two time base. It has two time base. Whereas in a CRO, as we mentioned, it has only one time base, which we said it's on the X plates. Then we can also say that electrons light the whole screen for a TV tube, and that's why you are able to see the whole screen being lit in a TV. So the electrons light the whole screen. The whole screen. Whereas in a CRO, as we said, the electrons will only form a spot. Electrons form a spot on the screen. This we were able to explain. So the electrons which are being produced in a cathode ray oscilloscope will only form a spot on the screen, unlike in a TV tube where the electrons will light the whole screen. Finally, there are 625 lines per second in a TV tube. There are 625 lines per second in the TV tube, whereas in a CRO, there are only 25 lines per second. So those are the differences, 4 differences between a TV tube and a CRO. In a TV tube, the deflection is by the magnetic field, and that's why the TV screen is larger than a CRO screen. Then we are saying that a TV tube has 2 time base, whereas a CRO has only 1. In a TV tube, electrons light the whole screen. In a CRO, electrons form a spot on the screen. In a TV tube, there are 625 lines per second, whereas in a CRO, there are only 25 lines per second. So that is it on the CRO, or the cathode ray oscilloscope. In the other lesson, which now will mark the end of this topic, we'll now be looking at the calculations involving the CRO. Now that we have seen, we can be able to calculate the voltage, we can be able to calculate the frequency, we can be able to calculate the sensitivity. So that's what we'll engage in. So I'd like to give you some exercise on what we have just covered on the uses of a CRO. So an assignment here for you. Answer the following. So that is the exercise. So we are told in question number 1, state one difference between the deflection systems of a cathode ray tube and the TV tube, which we have just explained. Then number 2, the beam of electrons is subjected to a strong magnetic field which is perpendicular to the path and into the paper. and into the paper. Sketch on the same diagram or on the same figure the new path of the electron. Then number 3, when using the cathode ray oscilloscope to display waveforms of voltages, state where the following should be connected. 1, the voltage to be displayed on the screen. And number 2, the time-based voltage. So that's the exercise. It's good that you answer those questions. And during the next lesson, we'll now look at the numerical calculations involving the cathode ray oscilloscope. Thank you.
Welcome to Manifested Publishers.
Welcome to our today's history and government lesson. Your teacher, Conan Gakure. It's my pleasure to have you in today's lesson. We are going to introduce a new topic, that is the establishment of colonial rule in Kenya. That is the next topic of Form 3 that we are going to be discussing. In this unit, we are going to dwell more into the Kenyan, the establishment of colonial rule in Kenya. In the previous topic that you have studied, we were learning about the European invasion and the process of colonization of Africa. We discussed how the European powers scrambled, were fighting, were competing against each other. Right? That is the scramble, the sudden rush. So the European powers rushed into getting colonies or territories in the African continent. That is what we defined as the scramble for Africa. And then after the scramble, they sat down during the Berlin Conference, if you can remember, that was held in which year? I'll give you that. You should be able to know the year in which the Berlin Conference was held, that was led by Otto von Bismarck, the Chancellor of the German Republic then. So they came down and sat and decided to subdivide, partition, share in an organized manner. That is partition. So they partitioned Africa amongst themselves. That is the partitioning of Africa. So Africa was now subdivided as a continent. It was subdivided. Each European power took part of the continent for themselves. The European powers that were struggling or that shared the African continent, that they refer to as the African cake, right? Can you remember which are these powers? Can you mention them? The powers that subdivided or took territories in Africa, the European powers. Which are they? British, very good. We have the French, very good. We have which other? We have the Italians, we have the Germans, we have the Belgians, right? These are some of the powers. We had Portugal, some of the European powers that came to get colonies. Are you able to remember the reasons that we gave? Why were they so much interested in getting these colonies and getting each and every person getting a portion of the African continent? There were so many reasons that we gave. We divided them into social, into economic, political, human, and then the strategic reasons for them scrambling and partitioning Africa. And we are not going to dwell in that because we have already tackled that. So based on that, now we come down into and look at now how the Kenyan territory was colonized. And the first thing to mention, it was colonized by the The British took control of the Kenyan colony. But before that, I would want to give you a background of how they ended up coming to take position of Africa. So, of Kenya, sorry. Kenya is part of the East Africa. Kenya is part of East Africa. In East Africa, we have other nations. At that time, we have Tanzania, we have Uganda, we have Ethiopia, right? The eastern part of Africa. So there were different powers that were interested in getting the East African territory. Some of these countries are Germans. Germany was one of them. We had Britain. We had Italy. Right? We had Italy that were competing to get the East African territory. We also had the Portuguese, who had come earlier than these powers. Remember in your Form 1 work, the contacts between East Africa and the outside world. So East Africa had been exposed to the outside world through trade. That was the main thing that exposed the East African coast to this power. So by the trade, it attracted these powers to come and get colonies in East Africa. Because of the trade, people were able to know that East Africa is rich. And now these powers came and competed to get a portion of the East African part of the African continent. So these are the countries that were fighting. So they had, after the Berlin Conference, they had to divide the East African continent amongst themselves. They made a protectorate, and I'm sure you discussed that. You know what a protectorate is: a sphere of influence where power has been put in place. So Britain took control of Kenya, which is the land where we are living in. The boundaries of Kenya, we were colonized by Britain. So you ask yourself, what are the factors or what are the reasons why the British were so much interested in taking Kenya as their colony in East Africa? Because remember, they were competing with all these other nations. So there must be a significant reason or reasons why these powers are fighting or struggling to get each other, or struggling against each other to get part of the colony of Africa. So that is what we are going to be discussing. Let us start with that at that point so that we are able to go forward. So the factors, you can also refer to that as reasons for factors for colonization. Factors for colonization of colonization stroke occupation. Stroke occupation of Kenya. Remember, we are saying, and I've mentioned that it was occupied by Britain. So what are these factors that encouraged or made it necessary for the British to come and occupy Kenya? The first one was the source of the Nile. The source of the Nile. Remember, the Nile starts in Uganda, right? And we said it was very essential because Britain had occupied Egypt. So it was necessary for them to secure where the Nile starts because Egypt is a desert. They do not have their own sources of water. they heavily relied on the Nile as a source of water. It provided, the Nile provided water. It also provided silt that could be deposited on the shores of the Nile towards as it goes to drain into the Mediterranean Sea. So it carries along the topsoil from the highlands, from the East African highlands, the Ethiopian highlands. So it was very essential for the British to occupy Kenya and Uganda being one, at that time the British protectorate, so that they are able to protect the source of river Nile. Why? Because they had occupied Egypt, and as we discussed in our previous topic, Egypt was very strategic, or was very important to them because of the Suez Canal. So it was necessary for the British to come and occupy Kenya so that they could safeguard those interests, the source of river Nile. That is the first reason why they were very interested in occupying Kenya. Number two, they had strategic, Kenya had strategic interests, or the strategic position of Kenya on the coast, on the East African coast. So British had interest in India, right? They had interest in India. They had colonized India, and it was very rich for them. It was very essential. So Kenya was a strategic stopover position. It was a calling place for the British as they moved towards India. So they had to colonize Kenya so that they can safeguard their interest in India. They could easily move from Kenya to India in case there was need. So Kenya was of strategic importance to them. Remember, Kenya had very good natural harbors. So the British would come, dock at the coast, and take time as they move towards the Indian place. And then number three, they were searching for raw materials. They were searching for raw materials. Remember, it was during the time of industrialization. There were a lot of industries that had developed in Britain. Britain had become a superior power. Actually, it was the first country to power to industrialize. Remember in your topic in development of industry, Britain was the first to industrialize. So it had a lot of industries that required a lot of raw materials. Examples is what we have: cotton, there is tea, right? They could come and get these plantations and get these minerals and then export them or take them to Britain for the industries to produce. And then after they had processed the raw materials that have come from Kenya, they had also to look for market. So Kenya also provided a ready market. That was another reason or factor for the colonization or occupation of Kenya. So the British came because Kenyans provided a ready market for the goods. Kenyans, we were producing these raw materials, but we did not have our own industries to produce the clothing, to produce the shoes. So the British occupied Kenya in the interest that they could be able to get market for their products in exchange of the raw materials that they were producing, and also Kenyans were also willing to make payments for those goods. Let us look also at the other reasons why the British had to occupy Kenya